Hi there! Welcome to the 22nd episode of the Synth project, where we are going to build a synth together. We ended the last episode with all the issues on the keyboard controller being solved and the final schematic ready. So it is now time to put to fruition all that hard work by mounting all the components on the PCB created from the schematic, completing the assembly of the whole module, the testing, the tuning and the installation of the module in the rack. Let's begin! Here is the PCB I obtained from my supplier once I provided them with my design on Gerber files. It is a two-layer PCB full of components, but not full enough to have the need for multiple layers, like in the case of the LFO described in a previous video. It is now time to start soldering all the components on this PCB. Later we will test the circuit functionality and tune the one trim pot necessary for adjusting the current on the keyboard resistors so that we can have an increment of exactly 1 volt per octave. And here is finally the finished PCB with all the components attached to it. The module case is very similar to the one for the soft pot. The front panel has just one less component on it, which is the polarization switch, which does not make any sense for a keyboard, of course. The size of the front panel is identical to the one of the other controller. Only the depth of the case and the positions of the holes to attach the PCB are different, and that because this controller has a bigger and more complex PCB. Let's see how the real case looks like once it is 3D printed. Here is the case for the keyboard controller module. It just came out of the 3D printer, and so all its pieces are still disassembled. The upper and lower wings need to be attached to the rest of the body with the help of those small cylinders, useful for the alignment of the pieces. Here on the front panel you can see the holes for the 4 jack connectors, the one for the keyboard, and the 3 that provide the control voltage, the gate signal and the trigger signal to the other synth modules. On the side panel we can see the 4 holes to hold in place the completed PCB, which will be positioned like this one. And here is the assembled case. The wings are in place, and so the case can be attached to the front side of the rack with screws going through the wing holes. I still need to paint the front panel to give it a better aspect, and once the paint is dry I will attach the decals to label the various checks appropriately. Okay, now the paint has been applied to the front panel and it is also dried. I applied first a thick layer, which once dried was sanded, and this way I filled with paint all the small imperfections of the surface. Then I applied a couple more thin layers to actually paint the panel. Here is the drawing I designed for the decals. The drawing needs to be printed on special decal paper and then sprayed several times with thin layers of transparent paint, and that is to prevent the ink from being wiped out by the water, which we have to use when the decals are immersed in it to detach the film from the supporting paper. The process to attach the decals is always the same. Cut the excess paper, put the decal in the water for a few seconds, and once the film starts sliding on the paper, move it on the panel and get rid of all the wrinkles. Once dry, spray 2 or 3 layers of transparent paint on the panel to prevent the decals from detaching or scratching. Finally, remove the parts of the film that cover the holes in the panel. Another thing that needs to be done is to attach the copper tape to the back of the front panel and to the side panel that will hold the PCB. This tape will shield the circuit from electric noise and will also make sure that all the front panel components have their body correctly grounded. Apply the tape one piece at a time and then remove the part that covers the holes. Now the case is ready to connect the front panel hardware and attach the PCB. This is the final result of putting the components on the front panel. The only thing left is to solder all the cables that will connect the sockets with the PCB. Once that is done, we can install the PCB. And here is the PCB being installed on the side panel. After that, all the cables between the PCB and the components on the front panel can also be connected. As a side note, the connections for the keyboard mini jack are done in such a way that 1. The ground is on the body of the jack connector. 2. The point A in the controller schematic goes to the middle part of the connector, and this is the part that will provide the constant current to the keyboard resistors. 3. Point F in the controller schematic goes to the tip of the jack connector, and that is the part that retrieves the control voltage from the keyboard and passes it to the actual controller. I also like to use some zip ties to make more rigid the position of the cables, so they won't break over time while managing the module and installing it on the rack. To test the functionality of the controller, I made a few modifications to the original mini keyboard to simplify its usage with the final version of the controller. The circles in the schematic indicate the added components, and basically the existing behavior of the mini keyboard is preserved if used through the original connectors, but now there is also this new jack connector that can be plugged in the controller module, so it can be used in place of a real keyboard. And I also added another 100 ohm resistor to be able to have the whole 12 keys of an octave. Let's run now the test and make the initial tuning of the controller. The final tuning will need to be done with the actual keyboard once it will be available. Okay, we are ready for the test and tuning of the keyboard controller. This is the modified mini keyboard. You can see that there is now a jack cable going directly to the keyboard connector on the controller. And now we have an extra resistor over here, which is connected on one side of this cable, which is basically the ground, and on the other side is connected to the other 11 resistors or 100 ohms in there. The opposite end of the 100 ohm resistors goes to this red cable that goes basically to again to this cable, and this is the one that basically injects the current in all the resistors. And finally there is the last piece of the cable over here, which goes directly to the original output of the mini keyboard, which is basically where all the switches go to and are connected on one side. So basically when we press each of these switches, we should get a voltage between ground and one of these 12 resistors. And between the two ends we should have a difference of voltage of a total of 1 volts, exactly 1 volts, because we have a whole octave available over here. So right now I have the control voltage jack connected over here, and is attached to the multimeter, which I'm now setting to volts. And so now we should adjust the stream pot so that between this point and this point we have exactly 1 volts. We can see right now there is a slightly negative voltage. Let's see what happens if I push one of these keys. So we have 1 volts here, so we should have 0 over here. In reality we have 83 millivolts. So let's adjust a little bit the stream pot so the two ends will be different of exactly 1 volts. So I'm gonna try from here to increase a little bit the voltage and bring it 1 volt and 80 millivolts. Let's see if I'm going in the right direction. No, I have to go in the opposite direction here. So Let's increase it a little bit. Of course, when I change this end, the other end will change too, so I would have to control them on both sides, and this would have to be done in steps by approximations, several approximations. Okay, let's stop right here and let's see what happened on the other end. This is 1.063 and here we have 87, so we have to increase more over here. So we have okay, now we have 1.086 and here we have 89, so we have to increase a little bit more. What I'm doing basically is changing the current through all the resistors. So 1.094 and 90 millivolts, so I went a little too far. So let's go back a little bit. 93, 92, 91. Let's try now. 1.09. We should read 90 mil. Perfect. So this is 90 millivolt and this is 1 volt and 90 millivolt. So there is a difference of exactly 1 volt between the two ends. Now let's make sure that there is 1/12 of a volt between each of the two consecutive keys. So here we have 90 millivolts, here we have 181 millivolt, 272, 363, 454, 545, 636 millivolt, 727, 817, 908, 999 millivolts, and 1.9 millivolts. So everything seems to be fine. So the control voltage coming out from the keyboard seems to be perfect. Now we have to examine the gate and the trigger signals that are generated when we push in various ways the keys. So we will need the oscilloscope for that. Let's take a look at the oscilloscope while we do this then. Okay, so now I have connected the oscilloscope to the jack cable and I moved the jack cable to the gate connector so we can check the gate output and see what happened when pushing the keys. So let's go to the oscilloscope right now and let's zoom in. Okay, so I'm gonna push a key now and yeah, you see that whenever I push a key I have a gate signal, and as long as the key is pushed the gate signal remains high as it's supposed to be. So it seems to work very well. Now let me try with two different keys at the same time, one and then the second, and you can see there is no difference. Now I'm going to release the first key and still no difference. I release the last key and the trigger goes away, so it works perfectly. So now the last test, and for that I'm going to move the jack to the trigger output and let's see how the trigger output behaves. So back to the oscilloscope, let's push a few keys one at a time. Here's the trigger, trigger, trigger. So everything works fine. Let me push two consecutive triggers, so let's see if it works as expected. 1 and 2, perfect. And when I release the key, there is no extra trigger coming out. So it's perfect. Everything works as expected. So now we can install the module in the synth rack. Okay, so I'm gonna now put the module on the rack. Unfortunately, there is not much else that we can do right now because the keyboard has not yet been modified to deal with this keyboard controller. So I'm just gonna power up the module here, and then we will have to wait until we make a modification to the keyboard, so it will be able to generate the control voltages, and we will be able to do the final tuning to the keyboard controller and test it and start using it. So that's it for now, and we will work on the keyboard the next time. And you know, actually, it is true we don't have a keyboard, but we still have the mini keyboard. So I can just make some noise using the mini keyboard to see if the concept, at least, it's sound. So here's the mini keyboard. I'm gonna connect the CV output to the VCO so we can test it. Let's see. Let's disconnect these cables, which we don't need right now, and let's do some experiment. Put this over here. I'm gonna just connect the CV output to the VCO input and run a quick test to see if we can hear any difference in sound. So this is gonna go here. This is gonna go at one of the inputs on the VCO. Let's turn on the system. Let's turn on the power amplifier, and let's see what we get. Okay. Let's see. We have to increase some volume here. Okay. Let's give some range to the sound. This way. Let's see now. How do you think? Well, you get an idea of what a real keyboard can do with this controller, and so now I'm looking forward to see the keyboard ready and actually do some real playing with the synth. So, what do you think of the little demonstration using the mini keyboard? Well, I'm now really looking forward to making the modifications to the Casio keyboard I got from my friend to make it work with the new controller as well as the whole synth. I'll start working on that right away, so the next episode will be centered on the keyboard itself. And you don't want to miss the next episode, right? And since you don't want to miss it, and also any other future episode, I strongly suggest you to subscribe to the channel and to enable the notifications by clicking on the bell. Unless you have done that already, of course. I'll see you in the next episode, and as usual, happy experiments!